All right, welcome back. In the past videos for topic 2, we've been talking a lot about elements, locating them on the periodic table, and talking a little bit about their mass. So this is a good opportunity to put some of those skills together and talk about the mole, and looking particularly at things like molar mass. The information that we cover in section 5, like all the information I give, is extremely important, but this information is really important. If there were any section I would say to star and make sure you know how to do, it's this section right here. So we'll probably take 2 videos to cover this section. First video, I'll talk more about the information. Second video, I'll try to fill with a lot of examples. So with that, let's go ahead and get started. So first we need to talk about the mole. We introduced the mole in topic 1 as the SI unit for quantity. So the mole is a unit of quantity, like the dozen is a unit for quantity. The mole can be abbreviated as MOL. You're welcome, because that E is just really hard to write. So MOL is the abbreviation that we use for mole. Now the dozen is equal to 12. 12 donuts, 12 eggs. When we say a dozen, we know that it means 12. When we say mole, how many is that? Well, it's a lot. It's 6.022 times 10 to the 23rd things, particles. Just like 12 dozen can be 12 dozen anything. It could be donuts, eggs, flowers. When we say 1 mole of something, well, it depends on what we're looking at. It depends on if we're looking at an atom, an ion, a molecule, a formula unit, etc. So we need to know what we're looking at. But the mole is 6.022 times 10 to the 23rd of that thing. And that's a pretty large number. In fact, to give you an idea, if you had 1 mole of dollars, that's a lot of money, right? And you spent $1 billion every second till the day you died at the age of 70, you would have only spent approximately 0.01% of your money. And that's pretty significant, right? That's a large number. But we use a large number because we're dealing with really, really, really tiny particles. It's actually possible to hold a mole of something in your hand in the chemistry lab. Although you wouldn't want to do that because you don't want to touch chemicals in the chemistry lab. But you get what I'm saying. So we said particles, right? Because particles is generic. What could be a particle? Well, like I said, it could be an atom. It could be a molecule. It could be a formula unit. You might be thinking, what is a formula unit? For right now, because we'll talk about this in topic 5, for right now you can consider formula units and molecules to be the same thing. To answer the question though, formula unit is the term we reserve when we're talking specifically about an ionic compound. But that's a technical thing that we don't need to get into right now. We'll cover it later. But the idea still is there. So if I said you had 1 mole of argon, ask yourself, what is argon? Well, argon is an atom, right? It's not a compound. It's not a molecule. It's just an atom. So 1 mole of argon is the same thing as saying you have 6.022 times 10 to the 23rd argon atoms. It wouldn't make sense to say argon molecules because argon isn't a molecule. If I had 1 mole of water, H2O, well, what is water? It's not an atom. It's a molecule. So we'd want to say we had 6.022 times 10 to the 23rd molecules. If I had 1 mole of NaCl, NaCl technically is an ionic compound, so we would say we have that many sodium chloride formula units. But like I said, for right now, it's okay for us to just refer to it as a molecule. This number of 6.022 times 10 to the 23rd is called Avogadro's number, and it has the symbol capital N sub capital A. If you ever see that symbol, they're referring to Avogadro's number. By the way, Avogadro's number should be listed on the back of your periodic table. So you will never have to memorize that number. But I guarantee if you do enough practice problems, you won't even have to memorize it. You'll just know it. Now remember, 1 mole is a unit of quantity, just like 1 dozen is a unit of quantity. And you could have, if I said we had a dozen eggs and a dozen donuts, is the quantity the same? Yes, there is 12 in each. But is the mass the same? No, the mass would not be the same because they're different things. In the same way, I could have 1 mole of argon and 1 mole of, let's say, zinc. Would I have the same quantity of particles? Absolutely. But would they weigh the same? They would not. And so how do you figure out how much they would weigh? In other words, how would you figure out molar mass, which is the mass of 1 mole of a substance? Well, there's a way we can do that, and we're going to take a look at it on the next few slides. Notice, though, the units we use for grams per for molar mass, and it's grams per mole. So if I said something had a molar mass of 18.02 grams per mole, that means 1 mole of that substance would have a mass of 18.02 grams. I could go to the balance in the lab and measure out 18.02 grams, and I would know that I had 1 mole of that particular substance. Just to give you an idea of how you can have the same number of particles but different masses, let's take a look at 1 mole of helium gas versus 1 mole of water versus 1 mole of sodium chloride. Same number of particles, but they would have different masses. Where are these masses coming from? They're coming from the periodic table. So a molar mass, remember, is the mass in grams of 1 mole of any substance. This can be used to identify elements on the periodic table should we need to. How do you find molar mass? Well, here's what we do. We're going to list the elements in a compound. We're going to determine their mass found on the periodic table. We're going to multiply by how many atoms there are. And then finally, we're going to add these values. So this is not an example in your notes, but let's go ahead and do this one together. What would be the molar mass of H2SO4? First thing, let's list the elements. We have hydrogen, we have sulfur, and we have oxygen. Second step, what are the masses of each of those elements? Now, just FYI, to make our lives a little easier, I round all of my molar masses from the periodic table. I just go to 2 decimal places. Makes my life a little easier. So even though hydrogen is 1.0079, I'm going to put it as 1.01. If you want to put the whole thing like 1.0079, that's totally fine. It just makes my life a little easier. Just make sure you don't round it too much. Like I wouldn't round it to 1. All right, what's sulfur? I would round sulfur to 32.07. And oxygen, now notice oxygen is 15.999. So if I round that to 2 sig figs, or excuse me, 2 decimal places, it actually is exactly 16. I'm just going to put the 2 zeros there. So that's the mass of each of these elements on the periodic table. Step 3, multiply by how many atoms that we have. That comes from the subscripts in the formula. Looks like I have 2 hydrogens, so I'm going to multiply that by 2. I have 1 sulfur, so multiply that by 1. And then oxygen, I have 4. All right. So those are the masses for hydrogen, sulfur, and oxygen. Lastly, I'm going to add them together. So 2.02 plus 32.07 plus 64.00. And since I did 2 decimal places on all of these numbers, I'm also going to do 2 decimal places in my final answer, 98.08. And my units are grams per mole. If you ever use molar mass in a calculation, just to let you know, we will not base significant figures off of this number. And the reason why is because we technically could have been more specific with these masses, right? We just rounded them because we were trying to make our lives a little easier. So we're not going to base significant figures off of molar mass. All right, we are going to get into some calculations here, but before we do, we need to talk just briefly about molar volume as well as molarity. So we first talked about molar mass. Let's talk a little bit about molar volume. What do we mean by that? Well, first of all, I want to point out we are only talking about gases. This only applies to gases, so please make sure you keep a note of that. Based on the work of Avogadro, which we will actually learn more of later on in this course, it was discovered that 1 mole of any gas, that's right, any gas, hydrogen gas, oxygen gas, carbon dioxide gas, as long as it's a gas and you know there's 1 mole of it, then it's going to occupy the same volume. 1 mole of hydrogen gas will occupy the same volume as 1 mole of oxygen gas, as nitrogen gas, and so on and so forth. So long as the temperature and pressure don't change, right? So that we can actually come out to be a mathematical conversion for us. 1 mole of any gas at STP, which is standard temperature and pressure, is going to occupy a space of 22.41 liters. So when we go to do some problems here in just a moment, we can use the conversion factor that 1 mole of any gas will occupy a space of 22.41 liters, as long as the problem tells us that we are at STP, standard temperature and pressure. that's all we're going to need to get into here. We will cover more details when we talk about gases later on the semester. But this will help us when we start to do some mole conversions in just a moment. And then the last one, molarity. We will talk about molarity more in depth later on, but for right now, we just want to introduce what it is. What is molarity? Well, molarity, which has the capital M indication, is simply just telling us how concentrated a solution is. Like, for example, let's say I dissolve salt in water to make a solution of salt water. How concentrated it is could be determined by molarity. Molarity will be discussed more in depth in topics 9 and 10, but here's all we need to know. Molarity is moles of the solute over liters of the solution. In other words, molarity is a conversion factor. It can help us to convert from moles to liters. We would want to use molarity as a mole conversion to help us get between volume of a solution and moles when we start to do some practice problems. If the problem gives you grams, that can easily be converted to moles, and I'll show you how to do that. If the problem gives us the solution volume in milliliters, no big deal, we can convert that to liters using a metric conversion. And the sample problems that we do will show you how to do all of that. Alright, with that being said, there are helpful guides that I give you. There's actually 3. This is one of them. This is not in your printed notes, but this is one helpful guide. It may not look very helpful right now, and I totally get that. But this is going to help us figure out how to convert from one thing to another. Notice that moles is the central unit. If you are in moles, you can get to any unit you want. You can get to grams, you can get to volume, you can get to number of particles, you can get to solution volume. You can get to anything you want. So moles is the central unit. If I was given mass and asked to go to number of particles, I can't get there directly. I first need to go from mass to moles, and then moles to particles. I will show you how to use this helpful guide. Another helpful guide is this one right here. Notice that you can use this to help you figure out what do I divide by and multiply by. And then finally, this is the one that's in your notes. To be honest, any of those guides will help, but to be clear, you want to make sure you can do these problems without the guide. The guide is there just to help you get started. You should get to a point to where you can get the mole conversions done on your own. With that being said, I think we've got time to do at least one practice problem. So we'll try to get through one practice problem in this video. Okay, example 7. You know what, actually, I don't want to be rushed or anything like that, so let's go ahead and wait till the next video to do our example problems.